So I will be talking about 360 videos and the sickness symptoms that users are experiencing when they are watching these videos. And the background for the study is of course the sickness problem, which is surprisingly persistent problem. It has been around for a very long time, and so far there has been no good solutions for that. For example, Lawson in a recent review reviewed that something like from 61 to 80% of users get symptoms with head-mounted displays, and that's pretty much. But of course, the data from the Lawson study comes from a very long time, so I think that some of the results come from devices that are not that good. So basically, the older devices probably induce more symptoms than new devices. So in that sense, that might be a misleading number. But still, it's kind of a worrying number. And I have been worried for a long time that this prevents the breakthrough of virtual reality and head-mounted displays, and this kind of problem that should be somehow solved. And now, of course, the good question is that who are these users? So who is getting sick? And why do they feel sick? One possibility is that it's a psychological problem. I mean, or psychological issues. So it might be that these people are, for example, more introspective. They pay more attention to their internal feelings, and they kind of report those feelings more easily. I think this has not been properly studied, so this is kind of a thing that should be studied. On the other hand, it could be a physiological thing. So it could be physiological differences compared to the other parts of the population. So it could be that it's related to the oculomotor system, so the eye movement system or the system that is controlling the accommodation of the lens. Somehow it's operating in a different manner, or it might be an issue in the vestibular system, or it might be an issue related to the integration of all these systems. So maybe the integration of visual and vestibular data, for example, doesn't work so well, or is somehow hypersensitive. But so far, no clear model for sickness has been found. So that's kind of a problematic situation. So if we consider now this problem of sickness, then we can go to the current study. So first of all, in the current study, we wanted to find out what kind of individual differences we can find if we utilize like a modern, current consumer head-mounted display. Furthermore, we wanted to utilize contents that wouldn't cause strong symptoms. Because in many previous studies, the contents that have been utilized in the experiments have been selected so that they induce easily symptoms. So symptoms like some kind of roller coaster videos, so with fast camera movements or maybe some other kinds of fast full field motions. And the problem with these types of contents is that everyone gets really sick. So we thought that what would happen if we would very, very carefully select mild contents? Contents that wouldn't or shouldn't induce any symptoms. So we tried to find out 360 videos that would have a stationary camera and only a small amount of motion and no fast full-field motions. And the idea was that if we would utilize that kind of stimulus, it would enable us to find the sensitive participants. Because now the hypothesis here is that if we have mild videos, then most of the people don't get any symptoms, but the very sensitive people will get still symptoms. So we would be able to pinpoint those sensitive people. Secondly, of course, if we are utilizing mild stimuli, then any sickness symptoms that appear in the situation, they come from the device. Quite often when sickness, virtual reality sickness or cyber sickness is discussed, it is attributed to the virtual reality. It's the virtual reality that causes the symptoms. So it's the head-mounted display that causes the symptoms. Quite rarely the contents and the device are differentiated. But this is an important distinction because they are completely different variables affecting the sickness symptoms. So if we are utilizing mild stimuli, then the symptoms that we are seeing should come from the device, probably. So two good points that argue for utilizing mild stimuli in these experiments. Then, the time course of the symptoms. It is well known that symptoms increase as a function of immersion time. There has been many studies indicating that. It's not completely clear what kind of function there is. It's like linear function or some other function. So what exactly happens there? But I think that there is a consensus that the symptoms increase. Many studies use fairly long immersion times, so something between 30 to 90 minutes, which are in that sense good that you are sure to get some symptoms, and in that sense you get good results. But as there are not so many studies utilizing really short viewing times, we decided that how about if we would utilize only 5-minute viewing times and 15-minute and 20-minute viewing times, or 10-minute viewing times, just to find out that what happens when the immersion starts. Could we pinpoint the time point in which the sickness symptoms kind of start to emerge? And of course, this is also a relevant use case because in many like entertainment cases, it might be fairly short immersion time that participants are using. So in that sense, this is also an interesting like choice of immersion time. So in that background, we had two main hypotheses. First of all, we thought that probably, because we are utilizing so short viewing times, we would see only mild increase in sickness, so only minor symptoms would exist. Then we thought that still, probably there are some sensitive participants in the experiments who get more symptoms, but we had no idea what would be the amount of sensitive participants, because now we have short viewing time and mild stimuli, so it's very difficult to say what would happen. But these are like general hypotheses that we thought before starting the experiments. Then to the methods. So we had, just a moment, yeah. We had 92 participants in the experiments, and we tried to have equal number of males and females, and we almost succeeded. Slightly more males than females, but almost. And the idea here was that in some cases it has been reported that females experience, or at least report, more symptoms than males, so it's important to have an equal number of those. The mean age was approximately 24 years, so fairly young population, and from the range you can see that it was pretty tight group, so fairly small age group that we were able to get to these experiments. They were students from University of Helsinki, mainly from behavioral sciences, humanities, and environmental sciences. What was surprising to us was that 42% of the participants had previous experiences with head-mounted displays. And this kind of proves that head-mounted displays and virtual reality are spreading to the consumers, because so many had already some experiences with the head-mounted displays. And then we utilized a diffusion of innovations questionnaire and wanted to find out what was their technology attitude. And we noticed that 95% of the participants were either early adopters or early majority, so they had really positive attitude towards technology. So this kind of background about the participants, and this kind of important when we consider the results. So we could try to understand that are these background variables somehow related to the sickness symptoms? Oh, you have been, because it's different here. Well, I will go through it again. Yeah, because here it was visible all the time. I was wondering what's happening, because it's all visible here. This was a trick. So let's go through this again. So we will see 92 participants, so males and females. Mean age was almost 24 years. They were students from University of Helsinki. And this was the surprising thing. 42% of the participants had previous experiences on head-mounted displays. And this was also kind of surprising that most of the participants, almost all of them, had really positive attitude towards the technology. So this is like the background thing. So now I have to be careful looking between the displays, so I can see what's happening. All right, I will look there. So then, Stimuli Devices. We utilize Samsung Gear VR, so just a basic consumer device with Samsung Galaxy Edge 7 phone. And we selected 360-degree videos that were available in the net. And the idea was that the videos would have stationary camera and stationary content so that they would be mild. We selected 13 videos, like expert selection, and created 4 video compilations from those videos. The length of each compilation was 5 minutes. And then we utilized those video compilations to make video stimuli to 3 experimental groups. So in group 1, there was only 1 compilation, so that was like 5 minutes immersion time. Then in group 2, there was 2 compilations, so it was 10 minutes. And in group 3, there were 4 video compilations, so it was 20 minutes. And the experimental design is between subjects, so different participants participated in each of these groups. Then, the experimental procedure. So we started with visual screening. We screened for visual acuity and stereoscopic acuity. 1 participant was excluded because she didn't have stereoscopic vision. Then we had the training phase. So the participants put the head-mounted display on, and like we checked that it fit in, and the participant was seeing it well. And then we said to the participant that please, like, tune the focus of the glasses, because this type of glasses, they have the roll on top of the display so that you can like tune the focus so that it looks sharp to you. And we wanted to find out that what kind of focus the participants would have. And what happened here is that then we photographed the side of the display, because there is a small, I guess it's ventilation grill here. And actually, the position of that ventilation grill corresponds to the focus of the display. So then we photographed that, and we converted that to diopters, so that then we had some kind of approximation about the focus tuning in that situation. Then the participants watched 360 video compilations and filled in 2 questionnaires. So we utilized basic Simulator Sickness Questionnaire with 16 questions, and this produces 4 basic scores. So there is a total score, which indicates the total amount of symptoms in the experiment. Then there is a nausea score, which indicates the nausea type of symptoms, oculomotor score, which indicates the eye strain, eye fatigue type of symptoms, and then there is the disorientation score, which is like dizziness and all types of disorientation symptoms. So there are like these symptom clusters that we get from the SSQ. Then we also utilized the presence questionnaire, IPQ, with 14 questions, just to find out whether there would be any differences in immersion. But we didn't get any results from the IPQ, so I will not talk about that in this presentation, but I just mentioned that we did it. Then to the results. So what happened? What kind of simulated sickness symptoms did we obtain in this experiment? Let's start from the SSQ total. So what you can see here is that this is the SSQ total score from 0 to 35, and this is the 5-minute group, 10-minute group, and 20-minute group. And what you can see here is that at between 10 and 20 minutes, the SSQ starts to increase. So something happens here. And this was the statistically significant results. Then we can check what happens with the SSQ profiles. So here you can see now the SSQ profile scores, which are the nausea, oculomotor, and disorientation score. And now the colors correspond to the groups. So this 5 minutes, 10 minutes, and 20 minutes. So we have 5, 10, and 20-minute conditions. And what we can see in each of these cases that in 20-minute condition, the bar is higher. So the nausea symptoms, the oculomotor symptoms start to increase, but these differences are not statistically significant. But then in the disorientation symptoms, you can see that the bar is much higher, and this is slightly statistically significant. So we can see that kind of all the symptoms increase between 10 and 20 minutes, but especially the disorientation symptoms are increasing. So this is like the basic result. So it seems that fairly early, actually, the symptom levels start to increase. So then we wanted to find out whether there would be some differences in the participants. So we conducted a cluster analysis and find that there were actually two groups. So here is a dendrogram from the cluster analysis. The main point is to indicate that, okay, we can see that there are two groups, so that it can be divided to two main groups, which we named low score group and high score group, because now we made the clustering based on the SSQ. So then we can see what happens with the different groups. So here are the same results with the low score group. And now we have 5-minute condition, 10-minute condition, and 20-minute condition. And if we consider how many participants were in each of these groups, you can see that here it was 60, 65, so most of the participants. Here it's a bit lower already, 39%. And then the high score group. And you can see that now that the difference is large. So there is really clearly a group of people who get small amount of symptoms, and then group of people who get high amount of symptoms. And here you can see that even in 5-minute condition, 40% of the participants were already in the high symptoms group. And then in the 20-minute condition, most of the participants were there. Then we can check the SSQ profiles. So here are the nausea, oculomotor, disorientation scores. And again, the colors correspond to the minutes, so it's 5-minute, 10-minute, and 20-minute conditions. And you can see that these remain very low here, so nothing significant ongoing. But then if you check the SSQ profiles with high score group, you can see that the symptom levels are pretty high, and you can especially pay attention to the 20-minute conditions, which are the black bars. And you can see that in each of these conditions, the 20-minute condition produces the highest amount of symptoms. But again, especially the disorientation symptoms were quite high, although no statistical differences between times. But still, it is kind of visible that, again, the disorientation somehow drives the increase in the sickness symptoms. A bit surprisingly, we found no relation to background variables. So we tested for gender, age, visual acuity, stereoscopic acuity, head-mounted display experience, technology attitude, focus tuning. By the way, the mean tuning was 1.64 diopters. No relations. We found no connections between these background variables and the division to two types of sickness groups. So this was kind of surprising, because we expected that there would be some kind of connection. So what can we conclude from this study? First of all, even with mild 360 videos, the symptoms start to increase like already after 10 minutes. Small typo. So quite quickly, actually. Somewhere between 10 and 20 minutes, there is the start of the increase, and especially in the disorientation symptoms, this is visible. Second main conclusion is that there is a clear division to two groups. So some participants were clearly more sensitive to the sickness symptoms. And I think that if earlier results from earlier experiments would be checked, I think that the similar results could be found from there. So I think that this has been visible in previous data too. If one would go and mine the old data, you could probably see similar things. And the surprising issue was that no background variable predicted the differences. That was kind of a surprise for us. So this means that in the future research, we should really think that more background variables should be included. We should somehow think that what would be the possible factors that would affect the increased sensitivity to sickness symptoms. And I think that one interesting variable is psychological variables, personality variables that are related to the style, how people pay attention to their internal states. So I think that this is the direction that I will go in the future, and check whether I could find a predictive variable that would predict these different sensitivity groups. Thank you. That was my presentation.